I thought what I'd do is take the set of slides that Arden showed and point out why they don't support his conclusions. Just kidding, just kidding.
No, you're not, Suresh. No.
Well, but in any case, the point I want to make is that if you start out with the assumption that fine PM is killing people, and you make that your central assumption, then any observation can be fit to that or explained on the basis of that assumption. And it seems to me that a lot of members of this panel have gone beyond the issue of asking whether that assumption is true or not. In other words, a number of members of this panel are making the assumption that there is a causal relationship between exposure to fine PM and mortality, particularly cardiovascular mortality. Now, I want to talk about the uncertainties in the original studies that led a number of people in the panel to that conclusion. So if I might have the next slide, please. So first of all, we have only a meager understanding of factors that affect health in human populations. In particular, the role of socioeconomic status is very poorly understood. And if you look at Steenland's paper in 2004, one can see how poorly we understand the role of SES in determining mortality. I've already talked about the inadequacy of the currently used statistical model. I'll come back to that in just a minute. And the results are highly model dependent, namely they depend upon the statistical model that is chosen to perform the analysis. The estimates of personal exposure are not available in epidemiological studies, and the range of reported risks is huge. So, for example, originally we thought that there was uncertainty and we had to address uncertainty because we were trying to tease out small risks from noisy data. But all of a sudden now we have these studies that attempt to characterize exposure better, like the Miller et al. New England Journal of Medicine study and the Osto study, in which the risks are so large that they're totally implausible. Next slide, please. So here is an example of how bad the Cox proportional hazards model can be. This is the total mortality rate ratio for 40-plus cigarettes per day. This is taken from CPS-1, and the points on the graph, these are not modeled. These are actual data points because that data set was large enough for the rate ratios to be actually computed, estimated. This is taken from one of the National Cancer Institute monographs on tobacco smoking. I think it's monograph 8. So if you look at 40 cigarettes per day and look at the rate ratio starting from age 35 up to age 85, you see this pattern. I've put a smoother through the data, but you see the risk increasing to about the age of 50 and then going down all the way to almost 1 or 1.25 by age 85. And this is the phenomenon that Arden referred to earlier this morning. Well, if the proportional hazards model were correct, you'd get a horizontal line that goes across this graph. Well, if this model is used to control smoking or to control for other confounders in which the same kind of a phenomenon might occur, then clearly you're going to get biased estimates of the risks associated with smoking. Next slide, please. So the first is the point that I already made. The second point I want to make is that just because a covariate is entered into the regression and you enter many, many terms, does not mean that it has been adequately controlled. And again, I'll take the example of smoking. Pack years is a very poor measure for control of cigarette smoking because the risk clearly depends very strongly, independently on both intensity and duration of smoking. Next slide, please. So now the second point that I made, that results depend on model choice. And here again, I've chosen an example that I already talked about this morning. Let's look at the long-term studies, the reanalysis of CPS2 as reported in Krusky et al. In 2000. This is taken from table 37. If you look at single pollutant analysis, the fine PM relative risk is 1.20, highly significant. The fine pollutant, the SO2 relative risk is 1.49, again highly significant. If you look at two pollutant analysis, the fine PM relative risk falls to 1.03, becomes highly insignificant. That for sulfur dioxide remains robust and remains significant. Now, I don't think that this finding and such a strong result can be explained on the basis that sulfur dioxide is simply a precursor for sulfates and therefore should not be included in the analysis. I mean, that is just sweeping the problem under the rug. This observation needs to be explained and has not been addressed in all the studies of ACS2 that have taken place after this one. Next slide, please.